We will solve example 2.6 from the book Heat Transfer J.P.Holman 10th edition. Here the statement of the example. Calculate the critical radius of insulation for asbestos and thermal conductivity for asbestos is 0.17 watt per meter centigrade surrounding a pipe and exposed to room air at 20 centigrade with H value 3 watt per meter square centigrade. Calculate the heat loss from a 200 centigrade 5 centimeter diameter pipe when covered with critical radius of insulation and without insulations. So first we need to calculate the critical radius of insulations, and then we will need to find the heat transfer uh, of the pipe with and without insulations that is provided. So in the first case, when there is no insulations, means the pipe is it's kind of a bare pipe, there is no insulation provided, so this is case 1. In second case, there is insulations provided for the pipe. There is insulation provided in the second case over the pipe. This is the second case, and this insulation is provided for this pipe. So inside there is a pipe, and outside there is the insulation provided. This is the inside radius, that is Ri, and this outside radius is R0, and that is equal to critical radius of the pipe. Okay, so the given data that is provided, thermal conductivity of the insulations asbestos, so that is K, so that is 0.17 watt per meter centigrade surrounding a pipe and exposed to room air at the outside temperatures, room outside temperatures in both cases the same, that is 20 centigrade, so that is 20 centigrade, that is 20 centigrade. So we need to calculate the heat loss in both the cases when there is no insulations and when there is insulation. Inside temperatures of this pipe is the inside surface temperatures, that is Ti. The inside surface temperatures is Ti, that is 200 centigrade, and the outside temperature is inside diameters is 5 centimeter, half of the inside diameters, so 5 divided by 2, that is 2.5 centimeters. Or to convert into meters, just divide this 2.5 with 100, you will get 0.0. The heat loss in the first case per unit length is equal to convection heat transfer coefficients outside, that is H, and its value is 3 watt per meter square centigrade. It is given in the statement, and temperature difference. So this is heat loss per unit length is H. Okay, what is this is the surface area, that will be equal to 2, and R inside radius in the first case, and the temperature difference, that is Ti minus T naught. So just put the value heat transfer per unit length is equal to H, that is 3 by 2 multiply Ri, that is 0.025 multiply by 200 minus 20. So after simplification, you will get the heat transfer per unit length. In the first case, when there is no insulations, you will get that is 84.8 watt per meter. This is the heat lost in the first case. So now let's come to the second case. First we need to find the critical radius. how much critical radius is provided over this pipe. So this critical radius basically tells us about the information how much at how much extent we are providing the insulation. So this critical radius, that is equal to R naught, and that is equal to K divided by H. So what is K? K of the insulation, that is 0.17 divided by H, that is 3. So you will get the critical radius, that is 0.0567 meter. Now if I draw the resistance network diagram for this heat transfer, so this the first heat transfer is occurs within the wall of the pipe. So it's a kind of induction resistance that is offered to the heat transfer. Then next is the convection exposed to the environment. Next is the convection resistance, and then finally the temperatures of the environment, that is T here at this point. There is the resistance, that is R1, and resistance, that is R2. This R1 is equal to ln R naught divided by Ri divided by 2 pi k L. Take L as 1, so I'm not writing it here L value. It is obviously it is 1. Now what is R naught? That is 0.0567 divided by Ri, that is 0.025 divided by 2 pi. What is K? That is 0.17. So after solving you will get the value for this R1, that is 0.766. Next is R2, that is equal to 1 divided by H1 outside convection heat transfer coefficients and the surface area, outside surface area, that is A naught, is equal to 1 divided by H1, then A naught is 2 pi R naught L, take L is 1, so 1 divided by H, that is 3 multiplied by 2 pi multiplied by R naught, that is 0.0567. After simplification you will get its value, that is 0.9356. So the total heat transfer in this case will be equal to heat transfer, that is equal to the temperature difference divided by total resistance offered to the heat transfer. So the temperature difference is 200 minus 20 divided by total resistance R1 plus R2. This is R1, this is R2, so R1 value is 0.766 plus 0.9356. So after simplification of calculators you will get the heat loss per unit length. For the second case, when there is insulation provided, is 105.78 watt per meter. So these are our final answer. So if you look at this value, the heat loss per unit length from the pipe. In case of insulations that is provided up to the critical radius, the heat loss from the pipe is maximum, but as compared to the one when there is no insulation provided. So it is obvious that if you are increasing insulations on a pipe up to its critical radius, maximum heat transfer, maximum heat loss from the pipe will occur from the wire, etc. Thank you so much. If